Okay, so we can actually also use Sage to do our Z sub P finite fields. And so for instance, for this example 1.1.4, where they look at the solution to this system, and we did something like this by hand. I think I might have, by hand, I might have had those switch, the 0 and the 1, but at any rate, we have this. I can put this augmented matrix into Sage, but I have to tell Sage, hey, we're working in Z2. And so the difference is that, so here I put that augmented system. Oh, there would have been a wrong answer. Okay, there's a 1. I put that augmented system in just like before. I asked for the reduced row echelon form. I display the results just like before. But ahead of time, I need to tell it, I want to work in Z2, and this is how I tell it I want to work in Z2. Now, I'm using an R here, an uppercase R, because that's what I copied from something on the internet. And so here, I also have to put an R. And so I'm going to scoot this over so it looks better. So I need that R there, otherwise it won't know. I have to, define it here to be Z2. Now, if I wanted to, so let's do this and just see what we get. And so here we get that Y had to equal 1, and that X plus Z had to equal 1. And let's go back to the book. And their solution said Y had to equal 1, and that X had to equal 1 minus Z, or X plus Z had to equal 1, and then they changed it to 1 plus Z because we're in Z2. And then they went through and they got the two possible solutions, since Z is arbitrary, but in Z2 it can only take the values of 0 and 1. Okay, so we get those solutions. We can read off that reduced row echelon form right there though, so this can do the calculation for us in Z2, so that's great. If we did not have that R, I'm not sure what would happen. I haven't tried that, so take that R out, evaluate, and notice we get a -1 there. This part's the same as it turns out, but we get a 1 and a -1. Well, that -1 in a way doesn't make sense, because we're in we should only get 0s and 1s. Okay, so we need to put that back. But again, now I'm going to use an R, but you could, if you like a Z better, because we're talking about Z2, just change those both to Z's. As long as they match, it's going to know what to do, and we're back to our answer that we had. And so we can, for any prime number that we want to use, well, you could use non-prime numbers, but we don't get the same number theoretical kinds of results with non-prime numbers. So we're going to stick to ZP where P is prime, and we're not going to do too much of it, but I think it's worth seeing, getting a little exposure to it, and given that this can do the calculations so nicely, it's not like it really is that rough on us. And so Sage can handle this modular arithmetic very nicely, so that's very cool. And there we go. That's Sage with ZP, or in this case, specific case, Z2.